Hello, everybody, and welcome to what will be 6.3 today, elimination using addition and subtraction. So, we have learned how to solve these equations a couple different ways. So today we're going to add one more strategy to that, and that is elimination, which I think most of you will enjoy because it makes a lot of sense. It's really easy to see, and the steps can go a lot faster than with substitution. So let's look. We solved different ways in the past. Substitution was the most recent. Today we're going to focus on elimination using only adding or subtracting. So we'll add something or subtract something to eliminate and solve for our two variables, x and y. Now some vocab for us today. We're talking about elimination, so we know that is there. And here are the steps that we're going to walk through as we try to solve these problems. So let us think about what these things mean. So first step, write the system so like terms with the same or opposite coefficients are aligned. So we want to write our x's, make sure they're on top of each other, our y's are on top of each other, and we want to be able to eliminate those that way. Second step, we'll add or subtract the equations so that one of our variables disappears. The whole point is to disappear or eliminate one variable. Once you do that, you can solve what's left, and you get one value, you can go back and find the other value. That's what step 3 says. Substitute the value you find, solve for what's left. Write that solution as an ordered pair, which we now know. As a reminder, looks like this. We have our x value, comma, our y value. This is how we want to write our solutions as an ordered pair. Great. So let's jump into it. First example today asks us to use elimination to solve this system of equations. So as we're working through this chapter, the wording on the problems is crucial because there are many ways to solve these problems. So you want to use whatever method they tell you to. So we've worked on graphing, substitution, and now elimination. So the directions will become really important as we look towards quizzes and tests. All right, so use elimination to solve this thing. So we've got two equations here. Notice the x's are on top of each other. That's exactly what we want. Our y's are on top of each other. They're all in line. And then we have our constants on the right. That's perfect. So everything's lined up. And the way this works, I think you'll like once we jump into it. So since the coefficients of the x terms are -3 and +3, those will cancel out if we were to add them together. So we can actually eliminate the x's altogether by adding the equations down. So we'll just vertically add everything down. And you're allowed to do this if everything is in line, and mathematically it will still be accurate. So we can write the equations in a column. So they're already lined up. They were already good to go here. We're just doing it again to make sure we're on the same page. And now just add everything down. So -3 and +3 becomes a 0. +4y and -6y becomes -2y. And then 12 plus 18 becomes 30. So mathematically, we're allowed to add these down if we have our equations lined up. So we get this. Now notice the difference between what we started with and what we have now. For starters, we had two equations with two variables, both x and y. Now we only have one equation here, and there's only one variable, y. So since there's only a y here, we can solve for this. -2 times what number will give me a +30? Well, if you're not sure, you can divide both sides by -2. And with your answer in a quick simplification, y will equal, you should be thinking, -15. So we're halfway there. Y is -15. So how do we find x? Well, just like the substitution we did yesterday, when you find one value, you have to go back and plug in, find the other. So you can put a 15 for y anywhere in these equations, first or second, doesn't matter, and then find out what x will be. So we will do that on the next slide. So now we'll substitute in. So here's the first equation. We're going to plug into that one. Could be the second or the first, doesn't matter, but we're going to do the first one. So y becomes -15 because we know that is true. And now we'll simplify. So 4 times -15 gives me a -60. Now we don't need the negative 60 next to our x because we want to eventually get this x value all by itself. So we can get rid of the 60 by adding 60 to both sides. This will cancel out. Over here we get a number. And with that step simplified, on the right we get 72. On the left we get negative 3x. Now, one more step to get x all alone. We need to divide both sides by a negative 3. If we do so, on the left we will get just x. On the right we will get 72 divided by negative 3, which should be negative 24. Awesome. And now to write our final answer, we found x, we found y, so we need to make sure we write them in the right order. So our ordered pair should be, if we remember the correct order, our x value comes first, so we'll write negative 24. And our x value is there, our y value is negative 15. So this is how you should write your answers here. Negative 24, comma, negative 15. That represents the solution for this system. The only two values that will work for x and y. And we can confirm that is true. Yes. Perfectly done. Negative 24, comma, negative 15. Great. So with that example in hand, you now see that you can solve these pretty quick. You make sure everything's lined up and go ahead and add them down. I think you all will like this method because it's just faster than some of the other stuff we've already discussed. So let me rewrite this equation over here so we have some space. So as you're writing this, I'm going to write it as well. Equal to 1. And then we have 2x plus 5y equal to 9. Great. All right. So if we're looking at this, is there anything here that we can eliminate if we add straight down? Well, our x's don't help us. We have a 3 and a 2. Those won't eliminate. They would just make a bigger x. But notice here we have, with the y, something that will help us. We have a negative 5 and a positive 5. And if we add those together, negative 5 and positive 5, those are opposites. They will come out to 0. So what we know with substitution, we can go ahead and add these equations straight down and get our simplified answer. So add 3 and 2 gives us 5x. Let's write this in blue. This becomes a 0, so we'll just leave that blank. And 9 plus 1 is 10. Great, so the y's disappeared. 5 times what number gives me 10? Well, I'll divide both sides by 5. Just to confirm, this goes away, and we get x equals 2. All right, so we are working well. We're halfway done with this problem. Now we need to find y. And we can eliminate answer choice A and answer choice C since those don't have a 2 for the x value. Okay, so let's plug in. Which one do we want to use? It could be first or second, doesn't matter. Let's say I'm going to plug this into my second equation. So I'm going to start back up here. So 2 times x plus 5y equals 9. Now we know that this is going to be x for our equation, but we found out what that value was. We're going to plug it in. It is a 2. So I'll just put a 2 here. Great. So 2 times 2 plus 5y equals 9. Now we can simplify. This becomes a 4. Here we have 5y equal to 9. Now what can we do to get our variable by itself? Hopefully these are making more sense as we work through these equations over and over again. Subtracting 4 to both sides will eliminate this number. That becomes a 0. All right, and now we have 5y equal to 5. Great. And 5 times what number equals 5? Well, we should all be able to see that the answer there, if we divide both sides by 5, y equals 1. Great. So as an ordered pair, we should have 2, comma, 1. Which is letter choice B. B has everything we need. 2 for x, 1 for y. So that's what elimination looks like. Now we're going to make this process a little bit more complicated. All right. So example 2 type problems ask us to solve our system, but we have to turn the words into equations. So let's read this and think about it. Of course, you don't have to write the words. We'll write the equations as we get to it. So 4 times one number minus 3 times another number is 12. So there's key words in here that we have to break down. We know the word is, for instance, means equals. So that's one thing that we have to throw in there. We also know 2 times the first number added to 3 times the second number is 6. Find the numbers. So let's turn those into x and y. So the first number mentioned will be x, the second will be y. Now here's what was said in that first sentence. So 4 times a number is just 4x. Minus is minus. 3 times another number, so now we use y, it's 3y. Is means equals, and 12 is obviously 12. So this whole sentence gives us this equation, and that's what we'll need to have for our equation to start. So please write that down. And then our second word phrase was here. So 2 times the first number should be 2x plus 3 times the second number is 3y equals 6. So here we have our 2 equations, and please write those down. 4x minus 3y is 12, and 2x plus 3y is 6. Now, we have to take this whole setup, see if there's anything we can eliminate, and add or subtract those equations straight down. So as we look, you should be thinking, which of those variables could you eliminate when you add or subtract those equations straight down? Okay, so we're going to use that elimination. So here's those equations that we wanted to have down. Now our goal is to eliminate. So we see 4 and 2 would add to 6, so that doesn't eliminate. But the y's are exactly what we want. We have a negative 3 and a positive 3. We add those together, that becomes 0. So they just disappear. We'll have one variable left, and that is something we can solve. Great. So y disappears. We get 6x equal to 12 plus 6 is 18. Y's went away. So 6 times what number will give me 18? Well, with one more step, we can divide and confirm. X would equal 3. So hopefully that makes some sense to us. Now we're halfway done. If x is 3, we have to go back, plug that into either the first or second equation, and find out what y must be if x is indeed 3. So we'll substitute in that 3 value on either equation. So say we use the first one. So x will become a 3, which we'll do here. And now we just have to multiply through and simplify as best we can. So 4 times 3 will become a 12. 12 minus 3y equal to 12. We have that now. So we have to get the y by itself. So we can subtract away this 12. We don't need that. We can do that on both sides. So we'll do that left and right. On the left, the 12s go away, so we just get the negative 3y. On the right, the 12s disappear, we just get 0. So negative 3 times what number would give you 0? Well, if you divide anything, 0 divided by anything is still going to be 0. So we know y must be 0. So our answer then, as an ordered pair, we already had x, and we found out that value to be 3. So 3 and 0 are the numbers that were originally presented in our problem. Of course, as an ordered pair, that would look like this. X value 3, y value 0, 3, 0. Done and done. Okay, so let's look at another one just like that. We have to take these words, generate an equation. So 4 times one number. 4 times one number. That to me is 4x. Added means plus. To another number, so y. And then it says is negative 10. So that's is negative 10. Now this phrase, 3 times the first number, that means 3x. Minus means subtract. The second number is y. And then it says is negative 11. So is means equals negative 11. So these are the pieces given from the words, and now we can write those equations. So I'll write it a little bit neater and all together here. So I have down 4x plus y equals negative 10. And also we have 3x minus y equals negative 11. Great. So if this is true, now we need to think about, first, is everything in line? X's, Y's, constants. Okay, that's good. Now, if everything's in line, we can add or subtract these things straight down. The X's won't eliminate, but will the Y's? Well, you can imagine there's an invisible 1 here, so it's just positive 1y and negative 1y. Those will become 0 if you add them. So we will add everything straight down and eventually eliminate the y's. So 4 and 3 is 7x. These y's become a 0. And here, negative 10 plus negative 11 is a negative 21. And 7 times what number is a negative 21? Well, we know 7 times 3 is 21. What would make it negative, though? A negative 3. And you can check by dividing both sides by 7. So x is a negative 3. And if you look at your answer choices, you know only one of these has a negative 3. So your answer must be A. And let's confirm that if we plug this in, we'll get the right y value. So we expect to get a 2 out. So let's see if that happens. I'm going to plug in our negative 3 into our second equation and see what y has to be then. So we have 3x minus y equal to negative 11. Now if x is a negative 3, I'll put that in here instead of my variable because I already know that value. So 3 times 3 is a negative 9 minus y equals negative 11. If I want to get rid of my negative 9, I should add 9 to both sides because those are the opposite signs. So this will go away. That becomes a 0. Over here, that's going to become a, you should be thinking, negative 2. So negative y equals negative 2. Now, anytime you have something like this, you don't want your variable to end up negative. It has to be positive. So you can actually just change the signs. That's multiplying everything by negative 1. So if you were to do that, this would then say y equals 2. So our answer should be negative 3, 2. And that is exactly what answer choice A has, so we know this checks out. A is correct. Negative 3 for x and 2 for y. So have all that as we look to make things a little bit more interesting with example 3 type problems. Okay, so here we have to eliminate. We're going to be asked to do it using subtraction now. So we've been adding down. We can also subtract. Same process, you just have to remember the signs. So since the coefficients in our x terms here, we have 4 and 4 again. If we subtract the second equation from the first, this will become a 0. And that's what we want. That's what all these words are saying. So notice we're subtracting now the second equation from the first. The one thing that trips people up with subtraction is that we want to apply the subtraction sign to everything. We cannot just change the sign of one term and forget everything else because then you've changed the whole equation. It doesn't mean the same thing anymore. So if we're going to subtract, every sign has to change in our second equation. So if I show you that step here, I'm going to write this in here. So if we're subtracting, that means every sign has to change, and then you can make this a plus. So I've changed the sign of everything here, and then made this a plus sign, and now I can add all these things straight down. Otherwise, if you don't do that, you have to mentally remind yourself that all the signs are different, and if you forget, you'll end up with the wrong values. So you can see now this whole thing makes sense. 4 minus 4 is 0, so that's why there's nothing here. 2 plus 3 is 5y. And 28 minus 18 is 10. So, if 5 times what number is 10, what must y be? We'll divide both sides by 5, and you know y is 2. So this is just like what we've already done. Only difference is the subtracting. You have to change all the signs and then go ahead and add everything down. So y is 2, we're halfway home. We have to plug in now and see what x is. So we can use first or second equation and see what we get. All right, so substitute that in. Say we use the second one. Where there's a y, I'll now add a 2. Looks like this. And now if I multiply through, 3 times 2 we know is 6. If we add 6 to both sides, we'll have 4x equal to 24. And that'll look like this. And now you ask yourself, 4 times what is 24? With the division, you can confirm that x must be 6. Great. So if x is 6 and we found y to be 2, we'll write that as an ordered pair. 6, comma 2. Done on this subtraction type problem. We're building all of these things into our tools that we can use to solve all of these systems of equations. So how about this one? We want to use elimination to solve this equation again. We're going to need to use some subtraction. So these are set up pretty nicely for us. So the x's won't eliminate, but our y's will if we just change the sign here, because we have 2 and 2. So if we subtract the second equation from the first, that'll help us. But I told you that you have to remember when you're subtracting the whole equation here, so all of these signs change for each term. So what I recommend is that you change the subtraction to a plus sign and then just change the sign of each individual term. That will make it much easier for you so you don't make any addition mistakes. So now, 9x minus 1 is 8x. Negative 2 plus 2 is 0, so nothing there. And 30 minus 14 is 16. So 8 times what is 16? I will now divide both sides by 8. Great. This goes away, and x equals 16 over 8. Comes out to be a whole number, so that's nice. X is 2. So if x is 2, we're halfway done. We know we can eliminate b, we can eliminate c as options. Now we need to plug in this 2 into one of our equations. So as I look here, the second one has smaller numbers, so I'm going to use that one because that'll be faster. So we have x minus 2y equal 14. But notice I left the blank here for x because we don't need to put the variable. We're plugging in the value, which we know is 2. So I'll put a 2 here. So now we only have a y left. We can solve it. I don't need this 2 that's on the left. So how about we subtract that away on both sides. This goes away. On the right, we're going to get an easy number. So we'll have negative 2y equal to 14 minus 2 is 12. And now one more step to get our y value for this one. Divide both sides by negative 2. And we are right about where we need to be here. These go away. We get y equal to negative 6. So if this is true, our ordered pair should be 2, comma, negative 6. Answer choice D has exactly what we need here. Answer choice D. So 2, comma, negative 6. We can add or subtract to solve for those variables. So 3b is done. And of course we confirm that is true. Now a problem with a bit of context. So let's not concern ourselves with the paragraph, but we will talk about it and make sense of problems like this in case you have to do one like that in the future. So a hardware store earned $956.50 from renting ladders and power tools last week. They charged 36 days for ladders and 85 days for power tools. This week, the store charged 36 days for ladders, 70 for tools, and earned this amount, $829. So how much does the store charge per day for ladders and for power tools? So all that I just said, everything in here has to be turned into two equations. That's the whole idea. So if we say X is the cost per day for ladders, Y is the cost for tools, we can write this as two equations. ladders, power tools, earnings. So they had 36, 85, and this was the dollar amount, so we'll write that. The second scenario they gave us was this: 36 for ladders, 70 for power tools, 829 for earnings. So these are the two equations you need to have down. As we now can apply everything we've already learned, we need to eliminate. We can add or subtract straight down to eliminate if it's possible. So the y's don't help us. These are not the same number, but the x's are. So if we were to add this straight down, we would get 72. But if we were to subtract the second one from the first one, this would become a 0. And that is exactly what we're looking for, as we now know, with elimination. So let's do that. On the next slide, we're going to eliminate by subtraction. Okay, so if we have this written down, one more step. Subtract away, this goes to 0. And I'm going to change the signs here to remind us what we're looking at and why the values are the same. So subtracting, change each sign. So this becomes a 0. This becomes 85 minus 70 is 15. And then here we get a value a little bit over 100. Now to get y alone, we're going to need to divide away the 15 on both sides. And y is $8.50. Or 8.5, excuse me. So now we can plug in 8.5 for y into either equation. So if we do that on the next slide, plug in here, 8.5. Now you can multiply through, you need a calculator to do all these calculations, but we're just showing the steps. 36x plus 722 and a half equals that. We can subtract away the 700, and 36 times some number equals 234. Divide both sides by 36, and we are done. X is 6.5. So, in terms of our problem, what does that actually mean? The store charges $6.50 for ladders, because X was ladders, and $8.50 for power tools, because that was the Y value we found a little bit earlier in the problem. So the idea is to use this context to help you solve these problems. Even if you have a paragraph, you can still figure it out, turn it into an equation, and then solve with the rules that we now know are true. So go forth and use elimination.